Hello and welcome to the video about discrete random variables. Okay, so like we said earlier, a discrete random variable is where all the outcomes are countable. Okay, they're all countable, and we have a probability for each random variable, and we put those together in what's called a probability model. Okay, so I'm going to show you the notation. This is very, very important that you really understand the notation right off the bat. So if capital X is the random variable, then the mean is denoted like this, denoted like two different ways. You could choose either way. Okay, that's this mu of x, mu of x, mu of capital X, or it could be denoted like this. Okay, or they like using words. E of x means what's the expected value. And I'm going to do it either way. You have to realize that these two mean the same thing. It's the mean of all these x's. Okay? And, okay, so it's the same thing. So if it was y, if it was capital Y, then it would be mu of capital Y or the expected value of y. And you can name these things whatever you want depending on the situation. It might be S, it might be T. Okay, so it all depends. So let me write we're going to do just doing discrete. So if you remember, let me just show you an example. So let's say we measured, okay, the number of phone calls per day. So X is the number of phone calls per day, okay, for some company, for some unnamed company. So they kept the data for a long time. So X is the number of phone calls. Okay, so I'm making a probability table because I could list them all. Okay, so my outcomes are 0. So this means that in any particular day they had no calls that day. Okay, next they had 1 call per day, 2 calls per day, 3 calls per day, and 4 calls per day. Okay, so this is the probability of X. So this is my probability model. Now I have to do the probability. So they measured this over a long period of time, and they had no calls on 5% of their days. So if they measured 100 days, 5 of them had no calls. Okay, this is 10%. 0.1 is 10%. So out of 100 days, 10 had 1 call. Okay, 40% had 2 calls. 30% had 3 calls, so 3 calls happen 30% of the time. And they had 4 calls 15% of the time. So you should know how I found this 15%. I added all these up and I said what's left to get me to 1, because this is 40 plus 30, which is 70, 80, and then plus 5, which is 85, plus 15, which is 1. So this is a probability table. Okay, so we need to find the mean of our x's. But this is how we say it. What's the expected number of calls, or what's the expected number of calls per day? And I could denote this as this, mu of x equals the expected value of x. Now look, which one happens the most? Okay, which one? You cannot do this. You cannot do 0 plus 1 plus 2 plus 3 plus 4 divided by 1, 2, 3, 4, 5 divided by 5. You cannot do this. Okay, And the reason you cannot do this is just a regular average. This is a regular average. Regular average. Now what's the problem with that? The problem with this is 2 needs to be weighted more and 3 needs to be weighted more. 0 is not happening that often. It only happens 5% of the time, so 0 should not be weighted that much into this formula. Okay? So basically what we need to do is, if you recall how to take the percent of a number, how do you take a percent of a number? So if I said find 40% of 60, said 40% of 60. 40% of 60 is going to be smaller than 60, right? Because it's a percent of 60. A percent, if it's under 100, is going to be less than whatever number you're dealing with. So all you would do is you would just do 60, change this into a decimal, times 0.4. And you will get 24. You just multiply 6 times 4. Okay? And it's less than. So take a percent of a number, you're multiplying that number times that percent. So what I'm going to do is, I said, well, 0 happens 5% of the time. So you have to find 5% of 0, or just multiply this. Well, 1 happens 10%, so 1 should only be weighted for 10%. These are actually how your grades are calculated too, when you have weighted tests and all that stuff. Okay, so 2 should be accounted for 40%, so you do 2 times 0.4, take 2 of 3 times 0.3 plus 4 times 0.15. So I'm taking account the percentage of every single case, and this is going to give me my expected value. Now I don't have to actually do 0, because 0 times any number is 0. So 1 times 0.1 plus 2. I'll go ahead and just do this out and pause the video to shorten time. We're back with 2.4, and that makes sense. So we think about what we have to do, set up our table, we showed our work. You always have to show your work, and then you talk about it. So we expect, we tell, think, show, tell. We expect about 2.4 calls per day. Now people get so confused with this sometimes because it's a decimal, and you could turn around and say, well, you can't really have 2.4 calls because that's 0.4 of a call. Okay, but this just gives you a rough outlook. Okay, this means in the long run. Okay, so in one day it might be 2.4. So what about the second day? The second day will be another 2.4, which is 4.8. So in 3 days it's another 2.4, which is 7.2. Okay, so as you can see, eventually this will be a whole number. So 4 would be, you expect the fourth day, you expect another 2.4, so that's 9.6. Okay, so on the fifth day, so this on 5, if I said, well, how many calls do you expect in 5 days? So this would be, you expect another 2.4, so 9.6 plus that would be, I believe, 11. So in 5 days you expect about 11 calls. Okay, so with anything, just like we added means before, we need to do a standard deviation. Okay, a standard deviation, and you should have an idea how to do this. Your calculator won't do it. Your calculator, unless you have like an Nspire or an 89, okay, your calculator won't do that. So when we find the standard deviation, remember we have to go through the variance first. So this is how it looks, the variance. Okay, the variance, or you could do the variance of x. You could do either one. Get comfortable with one, but you have to write notation. Okay, if you write notation on the AP test or any test, you know, it just shows you that you know what's going on. Okay, so make sure you learn this notation. I'm going to do it so much you're going to have to. Okay, so here's the formula. Okay, it's very similar to this, but it's a little different. So I'm going to take the random variable, or the random variable, the first one, 0. Okay, and I want to multiply that okay, times, sorry. Okay, this one you have to account for 0. It's the random variable minus the mean, okay? So it would be, this one is x1. I'll write the formula. Okay, I'm actually not going to figure it out. You guys can figure it out at home. So this would be x1 minus the mean, okay, and I want to square it. Remember, we square these, okay, to get rid of these negatives. And now I want to multiply that times how much this difference accounts for, okay? Because think about it, 0 is pretty far from 2.4, right? It's 2.4 away. So I square that, but that difference is only accounted for 5%. So whatever that difference squared is only going to get multiplied by that 5%. So even though it's far away, it's the lowest thing that's happening. So it's accounting for the least amount, even though it's pretty far away. So I want to add. Now do the same thing. So it's x2. This is my x2 minus the 2.4 squared times 0.1. Okay, and I'm going to put a parentheses there. And the reason I'm going to put a parentheses is because I don't want you to think the time sign is a decimal. Okay, so that's x2 minus mu of x squared times probability of x2. Okay, so I'm not going to write the formula anymore. Okay, so you should get the idea. 2 minus 2.4 squared times 0.4. That's a 4. Plus 3 minus 2.4 squared times 0.3. And you get the, for your homework, you might have to do 1 or 2 of these, and it won't be really long data sets, but you should at least go through the motions so you get it. You have an idea. So anyways, this is the variance, but the variance is increased. I squared it. Okay, so to go from variance to standard deviation of x equals the square root of the variance of x. So whatever you get here, I'll just write it like this. You take the square root of what you got up here, and that should take you down some. Okay, so that's an example of how to find the mean and the standard deviation of a random variable. And once you go through the book, there's a whole bunch of examples about insurance companies use this. Money wise, lotteries, anytime you pick a lottery, money won happens all the time. So they'll say, well, okay, if you play the lottery, okay, you're going to lose most of the time. This is money. Okay, you might win $5 sometimes, and let's say you might win $1,000 not that many times. So let's say this was a lottery game, and I set these probabilities up where, okay, so you're not going to win $1,000. So I could say, well, you can win $1,000. One person's going to win $1,000 out of 10,000. Okay, so I'll say 9,000 people will lose out of 10,000. So if 9,000 people lose and 1 win, how many more people will win $5? Okay, $5. So that would be 999 will win $5. Okay, so if I said this was a game, when you find the expected value, you're actually finding the expected value for one play. Okay, and I'm probably going to do more examples on this because I'm just showing you the formulas here, but you're not really getting it. It's kind of hard to see. Okay, because of this decimal thing. Okay, so if x was the amount of money you win, then this would be the expected amount. That'd be the expected amount of money you think you're going to win per one play. Okay, even though you don't want 0, 5, or 1,000, this is going to be some kind of a dollar amount. Alright, so that's it. Hopefully I didn't go too long. Kind of did, but it's good stuff. So thanks for watching.